Hi everyone. So this is the part 2 of paper 1 May June 2020. Question number 13a. Write 108 as the product of its prime factors. So in order to write a number as the product of its prime factors, we should divide it by the prime factor. So we normally start with the smallest prime factor, which is 2. So you have to check the number that you are given should whether it's divided by 2 or not. If it is not divisible by 2, you have to move on to the next smallest prime factor. So here the number is 108 and that is divisible by 2. 108 divided by 2, 54. Then again that is divided by 2, 27. Then we can't divide 27 by 2. We have to move on to 3. That is divisible by 3 and answer is 9. Again 9 is divided by 3. 3 divided by 1. Like this way we have to go till you get 1. Then after that we can write, now these are the prime factors. We have to write the number as the product of its prime factors. 2 into 2 into 3 into 3 into 3. You can write this. Now you will notice there are 2 2's, 3 3's. We can write it 2 to the power 2 multiplied by 3 to the power 3. Part B. Find the lowest common multiple LCM of 108 and 180. Now in this case, here you will notice 108 we already have written in product of its prime factors. Now we will try to write 180 as the product of its prime factors. So once we take 180, that is divisible by 2, 90, again divisible by 2, 45, but 45 is not dividing by 2, that is divisible by 3, 15, 3, 5, 5, 1. Like the earlier case, we have to go till you get 1. Then 180 can be written as 2 to the power 2, 3 to the power 2 and 5 to the power 1. Now we have to consider 180 and 108. I am writing 108 using the previous answer 2 to the power 2, 3 to the power 3. Now when you look at these two numbers, you will notice 2, 3, 5 are the prime factors that are used to write the two numbers. So when we have to find the LCM, we consider the highest power of each and every number. So when we consider 2, highest power, both have the same power 2. So 2 to the power 2. Then when we consider 3, this has 3 to the power 2 and this has 3 to the power 3. We have to consider 3 to the power 3. And 5, this doesn't have a 5 but this has a 5, so we have to have it as only 5 to the power 1. Then 2 to the power 2, 4, 3 to the power 3, 27 into 5. 5 times 4, 20 into 27, 540 is the LCM. Right. Question number 14, part A. In 2017, the population of Egypt was 97,500,000. Write this population in standard form. So in standard form, you know, we have to write the number in between 1 and 10 followed by a power of 10. So when we consider, ignore the zeros, consider the number that is 975. So how do we write it as a number in between 1 and 10? That is 9.75. The trick is always there should be only one digit before the decimal place, because when we consider the numbers from 1 to 10, there's only one digit. Then now I changed 975 to 9.75. So here the decimal place, it's like moved until here. Now see how many jumps? 1, 2, 3, 4, 5, 6, 7 jumps. So that is 10 to the power 7. So our answer is 9.75 into 10 to the power 7. Part B. The population density of a country is the number of people per square kilometer. In 2017, the population of Indonesia was 2.62 into 10 to the power 8, correct to 3 significant figures. The area of Indonesia is 2 into 10 to the power 6 squared kilometers, correct to 1 significant figure. Calculate an estimate for the population density of Indonesia. Now, we have no idea about this population density. That's why they have described it at the beginning of the question. The population density of a country is the number of people per square kilometer. So, in order to find the population density, we have to divide the population, or else a number of people, by the area. Now, here the population is 2.62 into 10 to the power 8. That has to be divided by the area 2 into 10 to the power 6. So when you have to divide the numbers in standard form, consider the numbers separately. That means 2.62 divided by 2. 2.62 divided by 2. 1. Here you have to keep the decimal place. 1.31. Then in the powers, when we divide, we have to subtract the powers. So 8 minus 6. So that's going to be 10 to the power 2. So our answer is 1.31 multiplied by 10 to the power 2. Question number 15. You are given a Cartesian plane and you can see there is a shaded region here. They say the shaded region is defined by 3 inequalities. Find these 3 inequalities. So that is really easy to get these 2 lines first, because you will notice these lines are parallel to the axis. When we consider this line, that is parallel to the x-axis and it cuts the y-axis at 3. So we can easily write this equation as y equals 3. Then when we consider this, that is parallel to y, cuts the x-axis at 5. So that is going to be x equals 5. But this one we have to find the equation. Here you will notice the y-intercept is 1. Okay, other than getting that one, now consider this point, this one, it is 2, 3. This one, 5, 6, right? So what do you notice? The x coordinate and the y coordinate. Here, the y coordinate is 1 greater than the x coordinate. Here also the same thing. So the equation for this is y equals x plus 1, because the y coordinate is 1 greater than the x coordinate. But they are the equations, right? They ask the inequalities here. So when we write the inequality, if I take this line, this is y equals 3 and we consider the upper part, that means y greater than or equals 3. This is x equals 5. We have to consider the smaller side. So x smaller than or equals 5. This one is y equals x plus 1. We are considering the below part, which means y smaller than or equals x plus 1. So hope you can remember, in this one, since we have the solid lines, we have to put the equal sign as well. But keep in your mind, if you are given a dotted line, we are putting only the inequality sign. Question number 16, it's regarding the set notation, the Venn diagrams. You are given Q. This is, I think you are quite familiar with this notation. This is the notation for the subset. This is the intersection. This is the null set, the symbol for the null set. So what does this mean? Q is a subset of P. That means the set Q should be inside the set P. Complete the Venn diagram to show sets Q and R. So we are given the set P. So Q is a subset of P means the set Q should be included in this circle. Then at the same time they say P and R, the intersection is a null set. That means there are no common elements in P and R. That means when we draw R, that should be a separate circle when compared to this P. So you can draw a circle which is representing R. Then for Q, that has to be inside the set P. Always make sure that you label the sets that you are drawing. Question number 17, that is relating to the sequences. Here are the first 4 terms of a number sequence. So they are given T1, 1 squared plus 3 equals to 4. Like that way they have given you the first 4 terms. Find T5, that means a 5th term. So you will notice a pattern here, isn't it? T1, 1 squared. T2, 2 squared. So if it is T5, that's going to be 5 squared. But when we consider this set of numbers, that is 3, 8, 13, 18. So you know obviously that is going to be 23. 5 squared plus 23. 25 plus 23, answer is 48. Part B, find an expression in terms of n for Tn. Now this one, finding this part is easy because you will notice here the position and the number they have used is same. So if they are asking Tn, here it should be n squared. Then this one, for this sequence we have to find the the nth term. So how do we get that? 3, 8. The difference is 5. 8, 13. 5. 5. So the difference between the terms are 5. So when we write the nth term for this, we have to write 5n because the difference is 5. Then how do we get the first term? From 5, it's minus 2. 5n minus 2. Right? So we always, once we wrote this one, 5n, we consider the first term. That means n is 1 now. 5 times 1, 5. But when we compare the first term, that is 3. So that's why we have to take away 2. You can consider this with another one. Let's take this one, third term. So 5 times 3, 15, minus 2, 13. So that is correct. Therefore, n squared plus 5n minus 2. So the expression for the nth term is n squared plus 5n minus 2. Question number 18 is related to a speed time graph. The diagram is the speed time graph for part of a car's journey. So you will notice the x-axis is in t, time, t seconds. Y-axis is speed, meters per second. The deceleration of the car between 140 to 200 is 0.2. So the gradient here, the deceleration is 0.2. Find the value of v. Normally the deceleration is the difference, the change in speed. So when the time is 140, the speed is v. When the time is 200, the speed is 0. So the deceleration, which is equal to 0.2, is V minus 0 divided by 140 minus 200. Don't worry, you will get a negative number. That's why they say deceleration. You just have to consider the number. So we take negative 0.2 here. V upon negative 60. So in order to find V, that is negative 0.2 into negative 60, that's positive. 6 times 2, 12, 0, 12. So it's 12.0. So the speed is 12 meters per second. Part B. The car travels a total of 1800 meters in the 200 seconds. Find the value of t. Now, you must remember, in a speed time graph, the distance traveled is the area under the curve. So, they have given us the distance is 1800 meters, which means the area of this trapezium is 1800. So, we'll write the formula for this one. For the area of the trapezium, that is half into sum of the parallel lines into the perpendicular height. So, half into sum of the parallel lines. So, here 200, here 140 minus t. That is the distance. Into the height is 12. We found the speed as 12 and that is equals to 1800. Now we have to do a small simplification. 140 plus 200, it is 340 minus t into 12, 1800. This 2 and 12 simplifies. So it's 6. 340 minus t equals 1800. You have to divide it by 6. 340 minus t equals 300. Then t here, 300 come into this side, minus 300. So the time is 40 seconds. Capital T is 40 seconds. Okay. This is the end of our second video. Please subscribe us for more updated videos. Thanks for watching.